So, Assalamualaikum and selamat petang to my lecturer, Cik Wan Husni Zain bin Wan Muhammad, and to the people who are viewing this video. My name is Ang Darren, number matrix 04DAD23F1035 from class DAD2B. Today, I will be making my presentation for subject Automotive Technology 1, code DJA 20013. So before we begin, there are 12 questions to be answered. So without further ado, here we go. So first question, demonstrate how to calculate the displacement or cubic centimeter (cc) of the engine and give one example of the calculation. So we all know the general formula to calculate displacement is D equal to pi per 4 times B square times S times NC, which B stands for cylinder bore, S times for stroke length, and NC times for number of cylinders. As an example, a 4-cylinder engine has a stroke length of 9 cm and the bore is 5 cm. What is the displacement? So by inserting the values into the equation, we will get the final answer, which is 706.86 cubic centimeters. Let's continue. So for question 2, demonstrate and explain the term of firing order. So in a nutshell, the firing order is the sequence in which the cylinders deliver their power strokes. It is designed into the engine. The crank pin and the camshaft arrangement determine the firing order. In most engines, the firing order evenly distributes the power strokes along the crankshaft. Most designs avoid firing 2 cylinders, one after another, at the same end of the crankshaft. Firing orders for the same type of engine may differ. This means that in a 4-stroke cycle of an engine, the operating cycle and the firing order would be first, third, fourth, and lastly second. It will not be in a continuous streak, which is 1, 2, 3, or 4. It will distance itself evenly between the 4 strokes. Alright, that it's for question 2. So on for question 3. Demonstrate how the valve overlap timing can affect engine performance. So the intake valve opens a few degrees at TDC, which is top dead center, and closes at BDC, bottom dead center. This permits additional air-fuel mixture to be drawn into the cylinder because of the intake manifold velocity. The exhaust valve opens at bottom dead center on the power stroke and forces out exhaust gases from the cylinder. The exhaust valve closes at top dead center. When both valves are open for a short period of crankshaft rotation near TDC on the exhaust stroke, the incoming air-fuel mixture helps purge any exhaust gases from the cylinder. Early overlap may result in exhaust gases being expelled into the intake manifold, and late overlap may result in exhaust gases being drawn back into the cylinder. So, as a reference, up here we have the valve timing diagram, which shows that the valve overlapping during TDC and during BDC. So the order, it has a few reference back to question 2, which is 1, 4, and 2, 3. So yeah. Moving on. Alright, so question 4. Demonstrate and explain the MyVAC system in engine technology. So MyVAC, full name stands for Mitsubishi Innovative Valve Timing Electronic Control System, is a variable valve timing VVT type of engine technology developed by Mitsubishi Motors. MyVac varies the timing of the intake and exhaust camshafts, which increase the power and torque output over a broad engine speed range while helping spool a turbocharger more quickly. Initially designed to enhance performance, the system has been developed to improve economy and emissions. To summarize, MyVac switches to the higher cam profile as engine speed increases and drops back to the lower cam profile when engine speed decreases. The reduced valve overlap in low speed mode provides stable idling, while accelerated timing of the intake valve's closing reduces backflow to improve volumetric efficiency, which helps increase engine output as well as reduce lift friction. And that is question 4. Let's go. Okay. Question 5. Demonstrate and explain the operation of engine cooling system. So, to begin with, we will go by point. First point, if the engine is cold, the thermostat may not open all the way. The coolant will circulate slowly and the engine temperature will be kept to the proper level. Secondly, a thermostat will remain closed until the water in the engine reaches a specific temperature. The water in the engine will circulate until this temperature is reached, but only in the engine. Methods are used to allow the pump to circulate water through the engine and not through the thermostat. Third, a method uses a spring-loaded bypass valve that opens and allows the water to re-enter the pump. The bypass valve spring is weaker than that of the thermostat and will be forced open whenever the thermostat is closed. When the engine is sorry about that. So, when the thermostat is open, the thermostat case will move down, pulling the valve open and at the same time forcing finger to close off bypass pipe. The fourth point, the thermostat constantly changes the size of opening depending on heat conditions. When the engine reaches the operating temperature, the thermostat will fully open. Then the coolant can circulate into the radiator. The last point, a fan pulls or pushes outside air through the radiator. This improves engine cooling, especially at idle and low speed. For the fans that are connected to the water pump, fans will always be turned by rotating water pump. For the fans that use electricity, the fan will not spin when the engine is cold. The fan will spin when engine temperature exceeds the set temperature. And here we can see a graph for the cooling system of engines. Okay. Then, followed by question 6. Demonstrate and explain the magneto ignition system. The magneto ignition system has the same principle of working like that of the battery ignition system. In this, no battery is required as the magneto is the generator. It consists of either rotating magnets in fixed coils or rotating coils in fixed magnets. The current produced by the magneto is made to flow to the induction coil, which works in the same as that of the battery ignition system. This high voltage current is then made to flow to the distributor, which connects the sparking plugs in rotation depending upon the firing order of the engine. This type of ignition system is used for small spark ignition engines, for example, scooters, motorcycles, and small motorboat engines. And here we can see a simple drawing made to understand the magneto ignition system. From the rotating magneto to the primary winding to the second winding, straight to the distributor, and then lastly to the spark plugs. So on. Question 7. Demonstrate the operation of ignition system. So Same like last question, this one is also about initial system. In a conventional initial system, there are two main sets of windings or circuits, primary and secondary. The primary circuit works on battery current and is responsible for carrying no voltage. Some breaker points and an ignition switch control this primary circuit. When the driver turns on the ignition key of a vehicle, its battery supplies 12 volts of current to its ignition coil through the contact breaker points. This flow of current creates a magnetic field around the coil. The secondary circuit is not electrically connected to the primary circuit. It has secondary windings in its coil and high tension lead between the distributor and coil wire on external coil distributors. Furthermore, it also consists of a distributor rotor, a distributor cap, spark plug leads, and spark plugs. The engine's rotation turns the distributor shaft cam, which separates the breaker points, which in turn stops the current flow. This leads to a collapse of the magnetic field around this coil. Lastly, when these contacts break, a high voltage current of 20,000 to 25,000 volts passes through the secondary winding. Then, the current flows through the high tension cable and reaches the distributor cap, which moves along the drive shaft's direction. Its movements are aligned with the high tension cables, corresponding to each spark plug. This alignment enables the cam lobes to open all contact points after each compression stroke of the cylinder. This lets the high voltage current pass to the respective spark plug, ultimately creating a spark. And here we can see a drawing diagram for ignition system. Oh, sorry. Okay. So, question 8. Demonstrate and explain the differences between recirculating ball steering system and rack or pinion system. Oops. So, for recirculating ball steering system, the manual recirculating ball steering gear, turning forces are transmitted through ball bearings from a worm gear on the steering shaft to a sector gear on the pitman arm shaft. A ball nut assembly is filled with ball bearings, which grow along grooves between the worm teeth and grooves inside the ball nut. This is the diagram for the recirculating ball steering system. When the steering wheel is turned, the worm gear on the end of the steering shaft rotates. Movement of the recirculating causes the ball nut to move up and down along the worm. Movement of the ball nut is carried to the sector gear by teeth on the side of the ball nut. The sector gear then moves with the ball nut to rotate the pitman arm shaft and activate the steering linkage. The balls recirculate from one end of the ball nut to the other through ball return guides. Then, for the rack/pinion system, this is the diagram for it. A rack and pinion steering gear assembly consists of a pinion shaft and bearing assembly, rack gear housing, two tie rod assemblies, an adjuster assembly, dust boots and boot clamps, and grommet mountings and bolts. When the steering wheel is turned, this manual movement is related to the steering shaft and shaft joint, and then to the pinion shaft. The pinion teeth mesh with the teeth on the rack gear. The rotary motion is changed to transverse movement of the rack gear. The tie rods and tie rod ends then transmit this movement to the steering knuckles and wheels, and then the vehicle will steer to the direction. following. Question 9. Demonstrate and explain how to execute the power steering pump bleeding. So, firstly, we bleed the power steering system when any hydraulic components such as pump, hoses, power piston are serviced. Bleeding a power steering system assures that all of the air is out of the lines, pump and gearbox. To bleed out air, start the engine and turn the steering wheel before leave from side to side. Keep checking and adding fluid as needed. This will force air into the reservoir and out of the system. Air can cause the power steering system to make a buzzing sound. The sound will occur as the steering wheels are turned right or left. So, in a nutshell, when bleeding a power steering pump, by turning fully from one side to another, we will be forcing the internal air to be pushed out due to the pressure from the steering wheel. So, such as this diagram. Continue on. Question 10. Question 10. Demonstrate and explain the differences between the sprung and unsprung weight. So, there are two types of weight in a vehicle: sprung and unsprung. For sprung weight, refers to the weight of all parts of the car that are supported by the suspension system, the frame, engine, body, and many more, all make up the sprung weight. And for unsprung weight, refers to all parts of the car that are not supported by the suspension system, such as wheels, tires, steering knuckles, rear axle assembly, and many more. The ideal situation is to have the unsprung weight as small as possible in relation to the sprung weight. The unsprung weight will then have minimum effect on the riding characteristics of the car. That is for question 10. So continue on question 11. Demonstrate and explain the differences between the wishbone and McPherson strut suspension system. So there are two types of suspension system. So there are two types of suspension system, which is the McPherson strut and the double wishbone or wishbone suspension system. For McPherson strut, this incorporates a single control arm that is connected to a long tube called strut. Shock absorber, strut, and spindle are integrated as one unit and supported by coil spring at the upper end and a lower control arm at the lower end. A ball joint is fixed at the lower end of the spindle. The lower control arm is also called as a transverse link. The lower arm is held down by a stabilizer bar. Meanwhile, a double wishbone means that two links, upper and lower, often parallel in the normal right position, are made in a wishbone shape to provide fore and aft stiffness and resist braking torque. Early design used wishbones of equal length, but the track variation caused considerable tire wear. Thus, this can be reduced by using wishbone of unequal length. The longer one at the bottom, but changes in camber angle will now have to be tolerated. So, differences and advantages between the McPherson strut and the wishbone suspension system are: the wishbone can withstand higher impact and bending force, will be more suitable for trucks or off-road vehicles, and is superior in dynamic characteristics for great load handling. Meanwhile, McPherson strut suspension system has a simple design, low manufacturing cost, and a lighter and long-lasting wishbone, and will be more longer lasting than the wishbone suspension. Alright, and lastly, final question. Question 12. Demonstrate and explain the operation of a single acting telescopic shock absorber. So, shock absorbers limit spring oscillations, compression extension movements to smooth the car's ride. Without shock absorbers, the car would continue to bounce up and down after striking a dip or hump in the road. This will make the ride uncomfortable and unsafe, and also damaging parts of the car. Figure shows the basic parts of a shock absorber. They include a piston rod, rod seal, piston, reservoir, compression cylinder, extension cylinder, and flow control valves. Most shocks are filled with oil. Some are air or gas and oil filled. When the shock is compressed or extended, the oil causes resistance to movement. The rod tends to drag slowly in or out. This dampens spring and suspension system action. One end of the shock absorber connects to a suspension component, usually a control arm. The other end of the shock fastens to the frame. In this way, the shock rod is pulled in and out to restrain movement. Shock absorber compression occurs when the car's tire is forced upward upon hitting a bump. Shock absorber extension is the outward movement of the piston and rod as the control arm moves down. This occurs right after a compression stroke or when the tire rolls over a hole in the road. And so that is it for the discussion of this presentation. I hope I have fulfilled every question's requirements of answering the questions. So yeah, and that is all. Once again, special thanks to my lecturer Cik Wan. Special thanks to my lecturer Cik Wan Husnizan bin Wan Muhammad, to my classmates, and to the internet, and most especially the notes I got from the subjects. So I will see you all again in the next video. Bye bye.